Which one of these can do more? Which one can make top quality parts that last the longest? Which one takes less time to make those parts? And which one actually costs less? Is it a 3D printer? Is it a laser? Or is it a CNC machine? I think we need to find out by comparing the Bambu H2D in laser mode against the H2C as the 3D printer, and we will be using the Carvera Air for the CNC machine. If you could only buy one of these machines, we're gonna find out which one makes the most sense to get first, so let's get into it. One of the most underrated benefits of 3D printing is in the design. It's much easier to design for 3D printing than almost any other method. And experience with 3D printing design is one aspect of it, but what I find is when you produce things on other machines, you have to have many separate parts. They all have to come together at the end. In 3D printing, it's nothing like that at all. We can combine them all into one, making design much quicker and easier, allowing us to focus in different areas like the function and also the looks. For our example today, I want to try MakerWorld's Lightbox Creator, which is through their Maker Lab tab, to convert my logo into a lightbox. So let's plunk my logo in, and it looks like we can select the printer that we want to use here, and I will be using the Bambu H2C. It's going to allow us for fast color swapping. The H2C also will allow me to make this pretty big. So it looks like we have some settings that we can adjust here for the colors, for the sides, the back, and also for reflective layers. We can also add a hole to hang on the wall, and we can also add holes for wiring. I also think if we're going to be adding LEDs inside here, we probably want to make sure we have decent ventilation as well, so we can keep this slightly away from the wall, and we can add a hole on the top and a hole on the bottom. That just makes sure that we don't trap too much heat inside there, which could deform the PLA. So this is our part. We have three colors. We have orange, black, and white. It's a good amount of color changes that are required for this part, but that's mainly because of the first few layers, and then it's mostly just one or even two after that. For our materials, I tend to buy in bulk because there are discounts when doing that. It's about $60 US for all of the spools of filament if I were to buy 4 of them at a time. Now, I'm not going to be using much of these spools for this particular project, so the black and white are going to be used on other jobs. I guess you could argue that it's just the cost of the orange and then tack on a little bit for the black and the white. Slicing a print for the best results used to be way more difficult, but these days it's really simple. Most of the time I just add a few extra walls and I increase the infill density and slice the print, and it is literally that quick. For some prints, I like the textured plate, but for this one, I think it would be better to try the smooth plate. I think it's going to provide a little bit more consistent and a professional look. One of the bigger issues that I run into with 3D printing is that I print so many different colors and materials that storage and also drying become a bit of a problem because they need to be kept from absorbing moisture. And also, if you're in a dusty shop like I am, they need to be kept clean so you don't have dusty filament bunging up your printer hot end. In other words, there are some hidden costs with 3D printing as well, and storage and dryers are a necessity unless you're lucky enough to print with only one material. It is definitely one of the cheapest methods for creating custom parts, and the cost for standalone 3D printers can be pretty inexpensive, especially if you can buy one that's used. If you want the premium workhorse printer like the H2C here, it will run you somewhere around the $2,400 mark US. It does seem like a lot, but even 8 years ago when I had the Ultimaker printer, it was not fully enclosed. It could only print one material at a time. It was as slow as molasses, and it came in at over $4,000 US at that time. Those machines do last a really long time, but the new machines are several generations better, and they're also cheaper, and they produce better results. So everything else aside, what really matters here is the final product. From a look standpoint, I think looks are actually still a problem with 3D printing. And the reason that I say this is because if we can detect that it's 3D printed from plastic, it automatically loses value. And when it comes to longevity, this is going to vary wildly. It's based on your expertise with 3D print design. It's based on the material, your printer as well. And if you're an expert in 3D print design, you might have a long-lasting finished part. So looks certainly are important when it comes to a 3D print. I think there's a little bit of room for improvement if I were to try and do this again. Instead of printing the black first, I probably would do the lighter colors first. And if I were to do that, if there were any sort of stringiness, it probably would go into the darker color and it wouldn't be nearly as visible. But a bigger issue, in my opinion, to the looks is the strength and also the toughness of a part like this, especially over a longer period of time, because this PLA filament does tend to get brittle. So one thing that I like to do with parts like this is I print them in a heated build chamber in the Bambu Lab H2C, and I do that ever since I tested that. That video will be up there if you want to check that one out. And I showed that we can get stronger parts because we have better layer adhesion when we do that. Now, as far as I'm aware, there's only 2 printers out that can actually print PLA inside of a heated build chamber. The H2C is one of them, and also the Qidi Max 4 is another one. The Qidi Max 4 has the addition of that polar cooler. So maybe one recommendation that I can make to 3D printer manufacturers is to improve print strength. Make sure you can print low temperature filaments inside of a heated build chamber. So moving over to the laser right away, we're going to have some design changes to make. One, because we're limited on the materials that we can use, and another because we're limited on mostly flat stock. Bambu has released some new features which do allow us to follow contours, but I think that's mostly for engraving, not so much for cutting. When we're talking about cutting, we are limited on the material thickness that we can cut. So this is one of my biggest issues with laser cutting, and that's that we rarely have a standalone machine. It's just really hard to design something to have a complete finished part when you're done. Programming a laser is usually pretty straightforward. Now I find that most brands have a lot of solid presets. It's not quite as easy as slicing, but it is pretty fast, and I usually have success on the first try with most materials. Okay, so this is what we are going to be cutting today, and you can see here we have the blue outline and then we have a white outline. Well, that represents the 10 watt laser cutting capability and then the 40 watt. And what I mean by that is the size that they can cut. Because the 40 watt is so much bigger, it's not just bigger in height, but it's bigger in the depth as well. We do lose a bit of cutting capacity, engraving capacity in the depth here, and that exists along the front. And you can see that there too. So this is the black acrylic that I have. I don't have any Bambu black acrylic that is intact. I've used it all up. And this is my problem here. So if I try and shut the door, I can't. It's just too big. So now I need to resize this so that it fits on properly. And that's a little bit annoying to have to do this. Now what, maybe I can put it sideways in the machine. Maybe not. Oh yes, oh yes. Now from a cost standpoint, lasers are usually far cheaper than a 3D printer in the actual machine cost. In my case, the H2D is not cheaper because it's a combo and it does several things, but generally speaking, a diode laser can just be a few $100s and on up from there based on their size. One of the other nice safety features of this machine is that on occasion, depending on what it is that you are cutting or engraving, it will force you to stay with the machine. And you have to press this check button to reset the timer. Definitely want to provide better support than I did. You can see how this side's falling down so badly. So you can see the laser line worked out perfectly. The cut around the outside looks great, but we need now white in this area, white for here and here, and then orange for the lower section. There is a bit of an issue with the white though. I don't have white, first problem. Second problem is that if I were to try and replace it with maybe clear and just scuff the surface up, that's not going to be an option either. The wavelength of light from this laser does not interact with this material very well. It is just a very low absorption. So it will go right through, it'll penetrate through, and it'll affect the backing, as you can see here. So that was a test from when I originally tested this machine. It does a great job on the backing material, but it doesn't even do anything with the clear acrylic, and that will be similar if we were to try it with white. So we are limited with options. We have green, we have orange, we have black, we have red, and there might be one more color as well. I don't see a dark blue on there, and that's just because of the wavelength of light that's being used here. It is a blue wavelength. So that said, we can actually do orange, and it is the right size to fit in this machine. I am going to leave the backing on, even though they don't recommend doing that. Material costs for laser are also pretty inexpensive as well, not quite as low as 3D printing, and that does come down a little bit to the way that we use the stock, because with 3D printing we have excellent material yield. In other words, what goes into the machine from the spool of filament usually comes out for the most part. But with a laser, we do not have that case. We usually have about 75% yield on a really good day with laser cutting, but it can be as low as 10% depending on the type of parts that you're cutting. Probably the most important factor with laser cutting is the safety aspect of it. The laser I'm using here and other lasers like it, for example, ones made by Xtool, are very safe because they've integrated all these sensors and cameras and preventative features for problems. Open gantry lasers are not that safe, the biggest issue being ventilation of fumes, the second being a fire hazard, or maybe the first could be a fire hazard. When I used an open laser, I would always do it outside. With these lasers, if the material is flammable, the laser forces me to stay at the machine to monitor it, which I think is really smart. Laser cutting does have one huge advantage. The parts that we cut are usually very high-end and long-lasting parts. Acrylic, for example, is an excellent material to use outdoors. It can take the heat of the sun and it looks great and shiny for years. Plywoods with the right finish on them as well can do basically the same thing. Solid woods can be a little bit tricky thanks to the huge variation in the density of the wood throughout. So they can be a little bit more difficult, but it is still doable, especially when they're just thin. So I think this is an area where the lasers really do shine. This is the first try I did, and it had 2 passes on it, and you can see what happened. Drop down, and then it tried to recut it. And of course we have those really dark burned edges, and there is quite a nice smell. I'm going to say nice smell. Some people might not find it too nice, but I do like the smell of burning cherry. When designing for CNC, there is quite a bit to think about. How are we machining the part? Can we do everything at once, or do we need to reposition to be able to complete that part? Material size is also a big limitation because material costs are quite high, and these are all considerations to make at the design stage. So I would put the design difficulty fairly high for CNC machining, though it really does depend on what it is that you're trying to make. There is a lot of flexibility with CNC machining, especially if you have a 4 or 5 axis machine, and I think in the future we're going to see more of those types of machines. But it is nothing close to what you can do with a 3D printer. Where you can really get bogged down with CNC machining is in the programming. It's just not very automated, at least not yet. So we have to choose the right tool for the job. We have a lot of flexibility on how we would want to machine these parts. Where do we position those parts, including how do we rotate them? How many passes, how deep per pass? Does it or does it not ramp in? Are we doing finish passes? Are we adding tabbing as well? Are we conventional cutting or are we climb cutting? And honestly, the list goes on and on. Not only does it usually require a paid software, it also takes a fair amount of time to do it. So for example, for these 3 parts that I want to cut here, these are made from acrylic. I want to make sure that they are the right size to match the laser cut parts. Then I sketched the size of my blank out, made my parts into components, and I was able to nest them onto that blank. And this can be done manually, of course. I think this method is just a bit faster. I went over to the manufacturing tab and I chose the contour cut and I selected a ramped cut. The bit that I'm using here is a 2mm diameter with an 8mm long flute. It is a single flute cutter. The shorter the flute here, the better, since these are tiny bits and they're prone to breaking. And if we don't get everything just right, if we break this bit, it's going to be $20 down the drain for a new bit. And then of course we have some lost time as well. So we're pretty well ready to go with the CNC machine. Now, if I were doing wood, I would be using a cutter like this, a compression cutter. So when it's rotating clockwise, it's pulling the grain up on the bottom and forcing it down on the top. And that way we have a really nice clean cut on both top and bottom. But we can't really use something like that for plastic. We need to have really good chip evacuation because we can't have excess friction because the plastic is really sensitive to heat and it could end up just melting it. So here's the cutter I'm going to be using instead. This is something like you'd see in aluminum as well. This is called a single flute spiral O, and it's a 2mm diameter. The shank is a 1/8 inch shank or 3.175 millimeters. And this works really well because we're going to have an up cut, so it's going to evacuate the chips pretty nicely. They're not going to get forced down into the cut. And we also have just a single flute. It's only going to be contacting once per rotation. I'll load it in. So here's the piece we cut with the laser, and if we place it on here, you can see it is a little bit too big for this platform. So unfortunately, if we were trying to do this black acrylic on here, we would have had to shrink the entire thing down, or maybe make it in several pieces. Now I use Fusion for my programming, but this does have a programming software as well. I just find that because I already pay for Fusion and I'm familiar with it, that's the one I like to use. Fusion's also quite flexible when it comes to programming. That's not good. Switching over to the 2mm diameter single flute. So obviously there's no cutting going on right now, and that's because I have a ramp height set, I think at 1.5 millimeters above the material surface. So we should start seeing it coming into the material. There we go. And we'll finish off with 2 contour finishing passes, the final one going 0.4 millimeters deeper, so we are guaranteed to go all the way through. We'll have a nice consistent finish on the sides, and they will be easy to remove and no tabs to clean up here. So the trick here, I think, is just to pick the right bit. We need good chip evacuation. We need to move fast enough so we're not melting the acrylic, but not too fast that we're going to have a lot of pressure on the side of the bit, and it has the potential to break. So I have it set at 1500 millimeters per minute. That's 59 inches per minute, and I have a spindle speed of 14,000 RPM for this machine, which is about the maximum. It's a lot that can end up as dust or chips, and they all need to be cleaned up. CNC machining has a lot more flexibility in the parts that we can make than laser cutting does, but less than 3D printing does. But where it really shines is in both looks, tight tolerances, and also in the longevity of those parts, reliability of those parts. Not everyone can do it. There is a lot of knowledge involved. There's a lot of experience involved. There is more to go wrong. There's higher material costs, higher maintenance costs, and most of the time, although not for the Carvera Air necessarily, the machines are usually more expensive as well. Between design time and programming time and figuring out how to secure the material down to be machined, it can take up a lot of your time. And like laser cutting, it's not really great to leave your CNC machine unattended as well. So you're going to have to be standing there or really close by while it's doing the work. I think if we were able to make everything from acrylic, I would choose that material because I know it's going to last, it's going to look good for a really long time, and it also can have depth to it as well, which gives it that appearance of high quality. Problem though is that they're not finished parts. We need to have something else to go with it unless we're designing just a flat sign. So what I'd probably do is design a 3D printed case and insert the acrylic into it. There are some similar limitations with CNC machining to laser cutting, but I think it's just much more flexible. We're not really limited as much with the materials that we choose to cut. On the other hand, it is much more time consuming to program. It's quite a bit messier, it's louder, and depending on what it is that you're cutting, it's not very forgiving all the time. So I put together a quick little chart here. I will link this down below if you'd like to check it out. But basically 3D printing came in overall 84%. So at the highest, CNC machining the lowest at 70%, 69%. And laser cutting and engraving was in the middle there. The biggest benefits of CNC machining are that we have parts that we know will last a very long time as long as we design them properly. And on the 3D printing aspect of it, it's extremely easy to use. It's extremely fast to program. And from a cost standpoint, it's pretty low as well. Laser engraving, there are some big benefits when it comes to the longevity of the parts that we're cutting, but there's some big drawbacks as well when it comes to the flexibility and it comes to the completeness of the parts or the assemblies that we're trying to make. It's extremely difficult to get a complete assembly when you're just using flat stock. So that said, if I could only buy one machine, I think I would have to go with the 3D printer first, but it does really depend on what it is you're making with these machines. The ultimate solution in my eyes is a combination of 3D printing, laser cutting, and CNC machining, but that's not always in the budget. Speaking of budget, I managed to get together some discount codes for both the Carvera Air and also for the X-Tool Metal Fab, and those are going to be down below in the video description if you've been eyeing one of those machines. And if you're looking at some 3D printers and want some recommendations, I have my top picks down there below as well. And one last thing, over the past 8 months, I've been working on a fully 3D printable Kickstarter project, and I have a video coming out in the next couple of weeks, so keep an eye out for that. Thanks to each of my patrons for helping to support this channel and keeping us going strong, and thank you for watching. Take care, and hope to see you on the next one.